Hello everyone. So what I'd like to show you is based on the presentation from Sharon, which is about the 3 phases of design process. I'm showing you an example how I have applied these in my design of this CE kettle, which you see in the middle there. The 3 phases are inspiration, going to ideation, then to implementation, and how this connects to the human-centered design. This new sort of kettle concentrates on maintenance issues and how people actually use it and what they would actually need and seek for. So what this kettle does is, it is all thermos, it's dishwasher proof, and it kind of disconnects from the technical part of it. The main issue with these kettles is that most of them break within 2 years. And the main issue is mold inside, lime scale especially, but also mold, which is a hygienic issue. And separating the heating part, which here is an induction part, and the bottle itself makes it possible not only then to put it into the dishwasher, but also to upgrade and maintain the technological part of it. So it's more hygienic, it's dishwasher proof, and keeps heat inside for much longer without any more electricity. So it's also possible to create a circular economy with it. That means that instead of the current take, make, and disposal system, you have the ability to send the product back to the company, they repair it or maintain it, and in the meantime you already have a new product, and the maintained product that the company will be used for next consumer in a brand new condition. If it's beyond the repair, you can recycle each part of it, which was important for this product to me. They have a few different materials, but can recycle them and reuse them. So how I've approached this from inspiration phase to user contact, what was important to me was that I could speak with people and actually listen to them. So the big part was actually to really listen and see what kind of information you can get and feel out of the situation from people. So it started with statistics based on research by Nazli Terzioglu, which is also a student from the RCA doing her PhD. And she gave me a lot of information, statistics based, how much goes into trash, how much goes into the ocean, how much goes into, how much material is actually wasted every year, which is almost as much as is consumed again every year, which I think in the UK, for example, is around 800 tons. So I went first to a recycling center and spoke to people there and looked at how many kettles actually end up there, and see if there's a difference between the statistics and the actual recycling center. What's the experience there? Then I made an online survey with around 100 people, and from all different sorts of people from around the world, people which have different cultures, people which have different statuses. No matter, every information was really good to work with. I spoke with baristi and tea makers in London, with colleagues, with family members and friends, and engineers to really see what's technologically feasible. These gave me the key insights. So this is from the recycling center. I found kettles between 5 pounds to 50 pounds, and both of them had around 100 parts, which I really like to reduce. And as you can see the lime scale inside, you can see the mold inside, and they simply broke because the parts overheated, covered in the mold and the lime scale, and changed shape, and water goes into the electricity. it's really hard or impossible to repair these. This is the online survey. I found out people don't actually would go for the £5 product, which is what you see on the top left. If there would be an option they are sure about it's going to last long, or you could contract with so you never have to worry about anymore, or something that looks simple and fits into every kitchen, something that you wouldn't mind looking at in 10 years or 20 years' time. It's just being timeless. And yeah, that were the questions about. And also some people gave me long emails back and explained how their situation is and what they would love to see, which was always interesting too. Speaking with the baristi and tea makers, I was starting to rethink about the size. These kettles use a lot of electricity to heat up a lot of water. Most people put much too much water in it. And the size is not that necessary. Most people don't use it for cooking. Most people use it for 1 cup of tea or 2. And this made me rethink the size and the scale, the proportion of it, and also the temperature. How much temperature is lost because you always have to heat it up again and again. What technology is available and what's actually possible with the packaging, and what would be probably feasible with a small amount of money. So I found this Chinese induction unit on the Chinese market, and it was pretty much the size I needed for it, and it was way too strong. I could use a much smaller, less strong unit, and that's the smallest available, but it worked for the design I needed. I checked out different materials for the thermos function. I was reducing forms and parts as much as I could, so in the end, the bottle on the top only had three parts, which did everything I needed, including the sealing, to have no pressure inside, but also cover it up to keep it warm. And I constantly tested again with colleagues, how does it spill? This is just a foam model, but already you can see how the water gets out of it and how it shouldn't, or how it maybe could. And that was always good insight as well. And I went through a lot of materials, a lot of tests with silicon. They're very, very great silicons right now, which are as much food-proof as they are heat-proof for any situation. Very, very water-repellent, which is important to have it easy to clean or not even have any sort of dirt inside, because it spills out with the water. And it is very capable of dishwasher use. Also, you can take the product apart by hand if you have some issues with it and want to take it apart. That's something that later happened on the exhibitions a lot as well. People love to touch it and take it apart. It was important with the lid. It was smooth, nice to touch, but also is enough rigid. And it influenced the look as well. People kind of, were very honest to me from the start. And that's the induction unit. So what was important there for me in terms of longevity is that you couldn't see the technology of the display. Displays change so fast that you can look at the product and see it's 5 years old or 10 years old. So what I wanted is that the display shines through the material. So you only see the font, the design, the graphic, but you don't see what technology is behind it. And as the product is something that can be upgraded through time from inside out, it makes it possible to have probably in 5 years' time a better display inside, but you wouldn't see it from the outside. But maybe it's more efficient or has better capabilities. And that was the final product. It was shown at the RCA show, and later on awarded also for the London Design Week, which gave the chance to have another big amount of people really giving feedback and somebody to chat and see what they think about it. And people would like to order something like that. So that really gives me hope that a system like a circular economy would work. That you have a contract like a car leasing contract or a phone contract where you only pay a little amount throughout the year, but you never need to worry about the product anymore, and not about its recycling either. Thank you very much, and I want to thank IKEA Stiftung Schweiz and the RCA as well for making young students not only reach their goals, but becoming designers with a heart and with social democratic abilities. Thank you.